A helpful property of a triangle tells us the measures of the three angles in any triangle always have to add to 180 degrees. If you've taken a geometry class, you're probably aware that this is the case, but could you explain why? If not, why should we believe it? As with anything else in math, we can use a proof to show why this has to be true given some simpler facts. In order to prove our angle sum works out to 180 degrees, we'll have to construct some new shapes. In particular, we can draw a line through one of the vertices of our triangle, C in this case, such that it's parallel to the opposite side, AB. Let's call this line DE. The reason we care about this line is that our sides AC and BC intersect both DE and AB, and angles that one line makes with two parallel lines have special relationships. In this case, take a look at these two angles. These are what we call alternate interior angles, and can be shown that they're congruent. If you haven't taken geometry, or if you need a refresher, two shapes being congruent means they're like we took the same object and put it in different places at different orientations. So to see why these angles are congruent, we can imagine taking our angle A and translating it up side AC. This new angle is what we call the corresponding angle to the original one, and if we compare it against the other marked angle, we have a pair of vertical angles, which are angles across from each other on the same intersection. These vertical angles also have to be congruent, and the most common explanation for why is because both of them have to add with this other angle at C in order to make straight lines. If both vertical angles have to measure 180 degrees minus that angle, then the vertical angles have to have equal measures, so they must be congruent. Alternatively, since the vertical angles are taking opposite sides of both lines, we can think about rotating one angle onto the other. Shapes which rotate onto each other are considered congruent, just like ones which translate onto each other, because both rotation and translation preserve lengths and angles. However you think of why our alternate interior angles have to be congruent, we have another pair of alternate interior angles on the right side of our figure. Now notice, these two new angles we constructed with the side DE combine with angle C in the triangle to make one side of a line. That means the total measure of those three angles has to add up to 180 degrees. But since we know that the single-ticked and double-ticked angles are congruent, specifically representing two of the angles of the triangle, this is the same as what we said before, that the sum of the angles of the triangle must be 180 degrees. And because we assumed nothing about the triangle in order to show this, we've shown that every triangle's angles must sum to 180 degrees.